We're going to be solving inequalities. This is lesson 5.7. Let's get started. All right, I want to just do some experimenting with inequalities. I want to see that if I add and subtract from both sides, that it'll stay true, similar to when we do equations. So 3 is less than 6 is a true statement. Are you guys with me so far? If I add the same thing to both sides, will it stay true?
Yes.
I have a 6 here and a 9 here. Is it still true? If I just bring that down?
Yeah.
Okay. What do you think if I keep adding bigger numbers? Will it continue to stay true? Like if I added 100, will it continue to stay true? Does anybody want to make a guess?
Yes, it will. It will stay the same.
You think so? I'll just pick them up and I'm just moving it down. And if you can see me on the screen, 3 and 6, or 3 and 6 for you guys are looking at it. You're just going to be moving it to get bigger, and they're still going to stay. 3 is still going to stay behind 6, or the number that represents 3 as we go along will still stay behind. But what if I subtracted some numbers? What if I subtracted it so far that we went negative? Like if I subtracted 5 from both sides. Will it stay true? Well, this will become a -2. And this will become a 1. Is that still true?
Yeah.
Yeah, that's still true.
What if I subtracted so much that I made both of them negative? Would that stay true? Let's go really big, like -10. This will become -7, and this will become -4. Is that still true? Just transferring that down. I heard 2 people. Is that still true?
Yeah.
Yes.
Okay. So we can conclude from this is if I am solving inequalities, when I add and subtract, it'll stay true no matter what. So let's do some examples with this. They're going to give you ones like this. Solving inequalities are almost the same as solving equations, but we notice that adding and subtracting is the same. But there must be a difference somewhere. We're going to find that in a little bit. So it says that this is a true statement, and to solve it, I'm going to need to subtract 6. And we said that if we subtracted the same thing from both sides, the inequality stays true, and so we're going to be fine. X will be left on this side, and 51 will be on this side. That's what we've been doing all along with equations, and now we have inequalities, and we can graph that with a 0 and a 51. Is that going to be an open or closed circle?
Open.
Open circle.
Open.
Going towards, this says that X is less than 51. Is it going to go towards the left or the right?
I don't know.
What numbers go in here and make it true? Are they smaller than 51 or bigger than 51?
Smaller.
Smaller, so we're going to go towards the smaller or towards the left. Okay? So we have graphed this and solved this. So adding and subtracting, it's the same with inequalities. Yeah. But let's figure out what happens when we maybe multiply. What if I multiply both sides? Oh, back up. Do that again. If I multiply...
As long as you multiply by the same thing, it'll still be equal.
You think so? So I do a 2 on both sides. I'll get 6 and 12. Is that inequality still true?
Yeah.
Yes, sir.
So do you think that if I keep multiplying by bigger numbers, it's still going to be true?
Yeah.
Correcto mundo.
What if I subtract smaller numbers, like maybe negatives? Is that going to keep it true? Let's see.
See.
This is going to be -6 and this is going to be -12. Is that inequality still true?
No.
I heard somebody say no and I heard somebody say yes. Which is it?
It's yes.
Is -6
No, it's not true.
smaller than is -12 bigger in this case because this guy opens?
Oh yeah, that.
So we just found the place that this is now false. When we multiplied by a negative, it became false. So to make it true, I am going to have to switch that inequality around. So what you need to realize that when you multiply by a negative, to keep the inequality true, you have to switch the inequality around. Just for the sake of time and all of us wanting to get done with this, I'm going to tell you that is the same with multiplication and division. If you multiply or divide by a negative, you must switch the inequality. Are you with me so far? That's a detail that you're going to have to remember. Let's do an example. Here's one. Oh, I didn't want that. Just a second. I'm going to take this one for a moment. We're not going to do this one for a moment. We're going to do this one right here. I have x over 3 is greater than 5. How do I solve this? How do I get the 3 off the denominator right there?
Divide it.
It's already being divided because it's on the bottom. How do we undo division? Multiply both sides. So I'm going to multiply by 3. Multiply by 3. If I multiply by something, do I have to switch the inequality?
It's x is greater than 15, right?
I have an x and a 15, I agree, but what do I switch this inequality?
Yes.
I heard yes.
No, that's only for negatives.
That's only if you multiplied by a negative. That is correct. So I did not multiply by a negative, so I keep this inequality the way it is. The only time you switch is if you multiply or divide by a negative. Let's do another one. Let's do this one that's listed right here. I'm going to move this x over by subtracting x and subtracting x. I will have a negative 6x minus 5 greater than 1. What do I have to do next?
Add the 5 to the 1.
Add the 5 to both sides. Make sure you're showing your work. It's getting harder and harder. There's more details. Negative 6x greater than 6. What do I need to do now?
You need to switch it around because it's false.
I need
Divide both sides by negative 6, but you have to swap the sign around, the greater less sign.
Exactly. I've got a big old alarm going off. Ding, 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 ding. A big alarm going off telling me I just divided by a negative. If I divide by a negative, I have to switch the inequality around so that it stays true. Notice they're different now than they were before. I switched the inequality around. I just divided by a negative. The alarm's going off telling me I have to switch it. Are there some questions? Up here at the top it says that solving inequalities is almost the same. The only time it changes is when I divide or multiply by a negative, and how I fix it is I switch the inequality around. I want you to try numbers 1, 2, and 3. And let me know when you're finished. I want you to have some practice before you do this on your own.
Done.
And 4 people are done. Okay, I'm going to come over here and I'm going to divide by 7 on both sides. Do I need to switch the inequality?
No.
Why?
Because you're not dividing.
I did divide. I divided by 7.
Well, no, it's only for negatives.
Okay, so it's only division of negative. So I did divide, but I didn't divide by negative. So it keeps the inequality. The inequality does not change. Okay. Here we go. I'm going to subtract 5 on both sides. X, and I have, what is that, 12? Do I switch the inequality around?
No.
There's a negative there. Why don't I? It's a negative. I thought that when we had negatives, we switched it.
Only when you're multiplying or dividing.
That's right. So, Zeb, what I'm going to have you do, write yourself a note somewhere on your paper that says something like, when multiplying or dividing by a negative, switch. Something to that effect to help you remember, Zeb.
Okay, I'm writing it down then.
Good
Now.
job. I like that. So we have not had to switch these so far. Zeb, you let me know when you're done writing it, so because I don't want to go too fast.
I just now got done.
Fantastic. I'm going to divide by -4 on both sides. X is going to be, I'm having a -5 over here. Do I switch the inequality?
Wait, no, it's not -5.
Yes, you do.
Why?
Because you're dividing by negative.
Dividing by a negative.
Very good. So it started out like that, so I got to turn it around. Asa, do you under...
Why isn't it -20 divided by -4?
Oh, I'm sorry. It's a -4 right there. So it's a +5. I'm sorry. Thank you very much, Asa, for correcting me. +5, but I switched the inequality. And I actually am going to write that in a separate color because just so you can really notice that I switched it around. Okay? Please ask me some questions. All right. We have learned to solve inequalities. And when we solve inequalities, they're almost exactly the same we were doing with equations. There's one difference. When you multiply or divide by a negative, what do you have to do?
Reverse the positive or the greater than sign.
Very good. We have to switch the inequality around. Very good. I like that.
Perfectly.
Say that
Do
again.
it perfectly. That's the easiest way to do it.
Do what?
Said do it perfectly. It's the easiest way to do it.
That's the easy way to do it. Just do it perfect. That's probably going to be the easiest. Thank you, guys.